question 12. So fx equal to 10 e to the power negative 0.25x sine x, where x is more than or equal to 0. So part A, show that the x coordinates of the turning point of the curve with equation y equal to fx satisfy the equation 10x equal to 4. So if it's about the turning point, we need to differentiate. So first we find the derivative. So fx is equal to, so it's a product, we need to use a product. So 10 e to the power negative 0.25x times by the derivative of sine x, which is cos x. And then plus sine x times by the derivative of 10 e to the power negative 0.25x, which is 10 e to the power 0.25x times by the derivative of the power, which is negative 0.25. And then we just have to solve this and make this equal to 0 and then rearrange that into 10x equal to 4. So 10 e to the power negative 0.25x cos x, and then minus 0.25 times by 10, which is 2.5 sine x e to the power negative 0.25x equal to 0. So because e to the power of anything cannot be equal to 0, so divide that for both sides. So we just have 10 cos x minus 2.5 sine x equal to 0. So then divide by cos x for both sides, then that'll be 10 minus 2.5 10x equal to 0. So that means 2.5 10x equal to 10. So divide by 2.5 for both sides, then 10x is just equal to 4. So that would be the answer for part A. And then part B, figure 3 shows a sketch of part of the curve with equation y equal to fx. So part B, sketch the graph of h against t, where hx is the modulus of the whole thing, where t is more than or equal to 0, showing the long-term behavior of the curve. Okay, so if it's whole thing modulus, so that means there's no negative y value. So basically what we should do, just try to make everything below the x-axis reflected up. So then the second half will look like this. And then the one already positive stay the same. And then the one below reflected up. And then stay the same, reflected up. And then so on. So that would be the answer for part B. And then the function ht is used to model the height in meters of a ball above the ground t seconds after it has been kicked. So using this model, find the maximum height of the ball above the ground between the first and the second bounce. So we're looking for the maximum height of the ball above the ground between the first and second bounce. Okay, so the first time, kick this, so it all goes up and goes down. And then once it hit the ground, so then that would be the first time bounce up and then goes down. So this would be the second up bounce. Yeah. So it says between the first and second bounce. So this is the first bounce, this is the second bounce. So the maximum height above the ground between the first and second bounce. So basically we're looking for the height of the second peak. So basically that's the second turning point. So to work out the second turning point, we already know derivative equal to 0 rearrange to be 10x equal to 4. So we have to just solve 10x equal to 4. So x is equal to tan inverse of 4. And then what's this? This is in radian, not in degree. So if it's in degree, they will put a little circle. Yeah. So if it's not in degree, if you can't see little circle, that means it's in radian. So then tan inverse of 4 in radian, that would be 1.3258. And then 10 is a 1 pi period. So we can plus another pi to be 4.4674. So since this is the second turning point, we're looking for the second positive x value, which is this one. So we just have to substitute this into the h equation. So h 4.4674 is equal to modulus of 10 e to the power negative 0.25 times by 4.4674 and then sine of 4.4674. the whole thing modulus. So if we put that in the calculator, so 10 times by e to the power negative 0.25 times by that long number times by sine of the angle 4.4674. So if we put that in the calculator and then take the modulus, so it should be 3.175357. So let's just keep as two decimal places. So that'll be 3.18. And then the units will be meters. And that's it for part. Well, actually, that's part C, not part B. Right, that's for part C. And then for part D, explain why this model should not be used to predict the time of each bounce. So because you can see to solve, so like this time interval is always the same because like to find the turning point is just solve this 10x equal to 4 equation. Yeah, you can see just plus pi each time. So that means the gap, the time between each button should always be the same from this model, which in reality it cannot be because like the height getting lower, the time should be less. It can't be the same. That's why we cannot use this model to predict the time of each bounce. So to write in sentence, we just say this model shows the time between each bounce is the same, but in reality, the time should be less after each bounce. So then that's all you have to say.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.